It takes quite some time to write these blog posts or email templates, and by the time I'm done and I want to hit the save button, often my access token is already expired. So what I then do is copy all of my work, hit the refresh button, and paste it in again to continue writing. That's of course far from ideal, so let's fix that in this video. We'll be refreshing the access token automatically. In my video about the HttpClient authorization handler in C#.net, I already showed you a potential approach to take to automatically refresh these tokens. I used a delegating handler to execute some code right before or right after our HTTP client sends out a request. That could be a GET request, POST request, PUT request, DELETE request, which all have the same underlying method, which is the send async method. So in there we could kind of intercept the request we're sending out, alter, maybe read out the headers, alter the headers, or even set some extra properties on the response if we needed to. You could also use dependency injection to either, in this example, inject the local storage service to read out those access token and refresh token, and maybe the expires in time, and then I could have added some logic to check whether the token is near expiry time, and if so, we could do a refresh tokens call. Instead of injecting this local storage service, it may be more efficient to inject the class that is responsible for refreshing the tokens. So for example, token handler, inject that class and just invoke the refresh tokens method on that class. But there's still a problem with this. This is going to trigger, so let's say that works, and within 5 minutes before expiry of the token, we want to execute a refresh tokens request. What if I haven't triggered any requests for the entire duration that my token lives, which is kind of the case when I'm writing these blog posts or email templates? Well, then the token is simply still going to expire. So for that, we can take a look at another approach, which would be using a timer. I'll be working in my brand website project, which you can get at kisco.com/products. If you want to follow along or get familiar with the project, grab yourself a copy, the V2, or go to my Patreon /GuessStupid and grab it from the shop. I've already implemented the timer feature to check whether my access token is near expiry by reading out the expires in property on the token, and if there's only 5 minutes left or 10 minutes left, then we're going to invoke a refresh tokens method. Now this timer is checking every 10 seconds. We can all, of course, do that every minute or every 2 minutes. By going to the application tab, I check out my tokens and I've got this expires in, but that's not enough because, well, expires in, that just says 1 hour, but I need to know when the token was issued, so I added that property, and then we can calculate when it's about to expire. And then every 10 seconds you see the console message, token expires at the expiry time and date, and then token expires in 55 minutes, which means it's a fairly recently token. So this project is using the .NET 8 identity endpoints, which after logging in, you get the token type, the access token, the expires in, which is an integer, which means the amount in seconds, The issue that I added, and then the refresh token. This is a bearer token, not a JWT, so it's kind of hard to see, to decode this and see the values in there. And then I added this issued at. Once we do the successful login call, right before we store the tokens into the local storage, I'll set this property to datetime.now. I'm doing this client side, so we're not having any conversion issues from server to client, no time zone issues. So that happens here right before I store them into the local storage. I set that issued at property. Now we can simply add a timer that runs every 10 seconds, 30 seconds, 1 or 2 minutes. I could write it all into the class, but I added that to my Razor component, since we can then nicely dispose this timer as well once the component is disposed, and so on. So there's at least 3 different timers that I could use for this project. I just went with the first one I could find, which is the threading timer, in which you can pass the method to execute and then a period and an interval and a timeout. So the timeout is after how long does the timer start. In my scenario, I only want to start the timer once I successfully authenticated and got a valid access token. So then I call the continue timer, which basically just adds the due time, so the timeout, and the interval, which is the period. So after the timer is going to wait for 30 seconds to start, and then it's going to execute every 30 seconds. By default, the timer, the timeout, and the interval is set to infinite. And also to stop the timer, I'm going to set this to infinite and dispose of the timer. So the method to be executed is watch token expiry. If we have a valid access token and issued at property, then if we don't have it, we're just gonna stop the timer if there is one, because we don't have a valid token and so on. We don't need the timer. If we have a valid access token, we are going to calculate the expires at and expires in values. So expires at is the issued at plus the expires at in time, and then expires in is how much time there is left for the token to be valid. If that expires in becomes less than or equal to 5 minutes, so 5 minutes until expiry time, then we're going to try to refresh the token. And I'm going to stop the timer and dispose the timer, because the next time we get a new token, we go through this flow again. So we should start the timer again and so on. And I'm not doing the refresh tokens call in here, but I'm simply invoking an event callback. Well, we might as well, so these are the methods I'm calling to refresh the token and then reinitialize the authentication state, so get the current user info and so on, authorize the HTTP client with those new tokens, make sure they're stored in the local storage. But why did I do this with an event callback? Of course, because this is an async task and we are in a void method. I didn't really find a way to make this, to call an async method or a task in this new timer. So For that, we could have used another timer approach, but we'll take a look at other timers in a minute in a different project, and more of a sample project. I still have an issue with this, and because I'm running a Blazor pre-rendered setup, which does a static render on the server and then re-renders when the interactivity kicks in, which causes some kind of double rendering, so things happening twice, anything in the initialized, for example, and also setting this timer. We now accidentally have two timers running, and that's exactly what you can see in the right screen. If I clear the logs, let's wait for 10 seconds. And you're just gonna see these expires at and expires in console logs are gonna happen twice. So within a very short period, at in. I could fix that in my sample project by simply not initializing that in there, since that on each render might create a new timer. It's also not as simple as persisting the timer into the component state or something like that and getting it out. Again, that's just not possible with a complex object like a timer. What I could do is maybe say timer, something like that. That used to work in my sample project. This continue timer should only be triggered when the auth state changed and I'm logged in. So from logged out to logged in, and this should only trigger after successfully initializing the authentication state, and which only happens on the first render. So this method shouldn't be called twice like the initialized may. I covered these double rendering issues in the video Prevent this Blazor pre-rendering issue C#.NET 8. This code still needs some debugging because I may want to run the timer and just anytime I'm authenticated, and maybe get rid of this, because that might prevent me from switching pages and having the timer still running. That's for later. I'm going to switch to the sample project with the glorious name of Blazor 1112 app. Let's see, I made a few components in here: counter 1, counter 1 async, counter 2, and I have counter 2 on the homepage currently. So counter 1 is similar like we just saw. Continue timer, pause timer. We're not filling the timer in here, or not in the uninitialized method, only in the first render, so we don't accidentally start two timers. Then this is just simply going to increment the current count, which is displayed on the component, and the watch count is incrementing that, logging the current count. If it's more than 3, that's a bit similar like checking for the token expiry, then we're going to stop and dispose the timer. I added this line, I'll talk about that in a minute. This has to do with multi-threading. Anyway, continue timer, so I'm creating the timer running every 10 seconds, pause timer in infinite, and disposing the timer. This project is just a default Blazor Web app with the render mode to set to auto, so server and WASM kick in. What I noticed with a server-side Blazor application with interactive server, or the old Blazor server projects, these tend to be multi-threaded, while the Blazor WebAssembly project, the client-side project, is single-threaded, which makes that sometimes if you develop a component in Blazor WebAssembly, you try to reuse it in the Blazor server project, it does not act exactly the same. I quickly opened my brand website project just to show you that. I do this task.delay of 2 seconds and then I reset the form. That form clears out all of the properties. What happens in Blazor WebAssembly if you change properties? So in the local state of that component, that usually causes triggers a re-render for that property wherever it's bound to the UI. In the Blazor server project or interactive server project, you may have to call this state has changed to kind of force that re-render after changing the properties. And I asked Microsoft why that was, well, the Blazor team, and that had to do with the difference in threading between the server project being multi-threaded and the WebAssembly being single-threaded. Anyway, their suggestion was, instead of calling state has changed, because even that didn't really trigger the re-render, they told me to await invoke async and then pass the state has changed method. So let's run that without this state has changed. If I just did this, state has changed, Visual Studio tended to crash on that. Maybe my hot reload doesn't, but or the debugger might crash on it as well. Let's run that. That would work in the Blazor WebAssembly project, but we are running with the auto render mode. Okay, so we're running counter. Oops. Yeah. So it crashed on that state has changed. And it's telling me the current thread is not associated with the dispatcher. Use invoke async to switch execution to the dispatcher when triggering re-rendering or component state. Here is the counter running, nothing in the console. And my project console, it's counting 1, 2, 3, 4, also logging whether we're in the after render async method, after render method, just to see when that triggers. And then once we have a count of more than 3, we say enough and we get rid of the timer. And if you take a look at the UI, you see the current count is on 3, which is good. If I would run without this task.run method, if I try the same thing, then it is not going to re-render that current count, or first count, but nothing changed in here. You can see console 2, still nothing in here. If we take a look at counter1.razor, it's doing the same thing, just using the system timers.timer, which has a different interface. Let's see, so we just watch count. Also still in that void method, invoke async to synchronize the context. Continue timer, we initialize a new timer, set the interval to 10 seconds, add an event handler, well, event callback, let's say. watch count, so that's that method above, and then start the timer. To stop the timer, we stop close, which is kind of like disposing the releases the resources, and dispose releases all resources. Pretty much the same thing. Still need that invoke async. Counter one async. It's also possible to use to specify it like that, the event callback and async method, and then await the watch count, on which we can then await invoke async state has changed. Pretty much the same. Then counter 2 is the periodic timer, which is more resembles a bit the background worker services, which, let's see, we're doing the same stuff. Watch count is an async task this time. Invoke async, we do need that state has changed. To run the timer, we initialize it, specify 10 seconds as a time span, and then do a while loop, which will trigger on each tick, so on every 10 seconds. And then we do a watch count. You may wonder, why is this relevant to refreshing the access tokens on expiry? Well, yeah, just giving you all of this side information because you need to kind of know what you're doing with these timers. So you need to make sure you're not accidentally running multiple timers. Let's now, just for experimentation, try to run on the interactive WebAssembly. But we're still in the pre-rendered mode, so server client. So let's see what that gives. WebAssembly. Let's comment that out. And now we should be able to. So on this counter component, I wonder, well, maybe because we're working with a timer, it's not gonna re-render, but let's see, because this watch method is probably being executed on a different thread than the local state updates and re-rendering. We could maybe do JavaScript interrupts to purely client-side single-threaded intervals. So now we're client-side, we're seeing timer continuing in this console, count to 1, we're not seeing the update. So we just have state has changed now, which without the timer shouldn't be necessary. Updating local properties should trigger a re-render. And now, state has changed is working because we're in that interactive WebAssembly. So we don't need to use that invoke async to synchronize the context. And the interactive WebAssembly way should be single-threaded. So that's why it works differently. But it's quite annoying if you're developing components to be reused over different render modes. Let's see what that gives. That should also just work, since it's likely already in sync. That's single threaded up. So that also works. If you enjoyed this episode, don't forget to like and subscribe. Don't forget to check out my brand website products, and I'll likely be posting the counter components and some of my authentication components to my Patreon, so check that out as well.